Technology is definitely throwing attention today. We're doing good to have made it this far. I've been like trying to get my stuff set up for like 30 minutes, and I'm like, ugh. And this is stuff that I already have on file, but for some reason it's just like, no, I'm not going to be here today. Like, wow, I've been using you for like years now. All right, let's shut this down. Let's open this. Hit done. Let me try to get the last few scragglers. Let's see. All right, so I think the live stream is going. It should be. And I went on and took attendance for everybody. Again, if you want to reduce your chances of falling into that second wave, which it doesn't apply to anybody here, just try. It's a good idea to be in the waiting room about 5 minutes before the start of class. Let me share my screen. Here and here. View. Just want to see it. It's looking good. Okay, I ain't gonna worry about it. Here. All right. Okay. All right, Scotland. So let's see. So welcome. Sorry for the delay in the start. Yeah, I don't know. We're probably in some kind of like Mercury retrograde or something. Technology always goes haywire, and it seems like we're always in Mercury retrograde. It has nothing to do with it. Morehouse. Yeah, myself was just throwing a tantrum. But anyway, we found a way around it. So let's see. So we're here. Hopefully, everyone had a good weekend. You were able to do what you needed to do and a little bit of what you wanted to do. A nice balance between the two. We are moving into week 3, right? So I think this is going to be the last topic in chapter 1 on graphs and functions that we're gonna explore. And so this week we're just going to focus on section 1.3 functions. So today we'll go through as much of the lecture as we can together. It's a total of 44 slides. Again, whatever we don't finish together, I do expect you to use my pre-recorded lectures. Whenever you're using my YouTube channel, as far as like recordings, there are 2 main playlists to have in mind. One playlist has all the pre-recorded lectures. I put that in one playlist by itself. And then I created a second playlist specifically for this semester, for the fall of 23. And it's basically a catalog of all of my interactions with the students, right? With you all. So, you just want to have those 2 ready to go. Hopefully you're finding your way through my math lab. I know we said the 2-week trial, so that should be ending soon. I don't know if anybody has bumped into like it expiring or not. So I had to follow up with my administrators to see if they ever negotiated some deal. I haven't seen anything in the email, so I have to reach out to them. So just let me know, like, I guess you would see it, but let me just reach out to them because I don't want to assume that you'll see it if it's there. Yeah. Okay. Well, I can't think of anything else. This is week 3, so we can anticipate exam 1 to become available. I think I said it for like this upcoming Sunday, and you can earn higher than 90% for like 7 days. All right. So from this Sunday until the next Sunday, you can earn up to 100%. After the due date, the highest you can earn is a 90 on any question submitted past then. Okay. So as usual, if you have questions about anything, feel free to unmute yourself to get my attention or type in the chat. I am monitoring the chat. There now. If you have questions, feel free to contact me now. Like you can ask me during class. I don't want to switch. I want to join. It's this one. Video off. don't connect my audio. All right, I gotta let myself in there. Stay as a participant. Okay, I think I can see what I'm gonna say. Okay, cool. Okay, so some objectives here for section 1.3 functions. One, we like to use functional notation and find function values. Two, we like to find the domain of a function. Three, we like to identify the graph of a function. Four, we like to get information about a function from its graph. And five, we like to solve applied problems by using functions. Okay. So some definitions here. A special relationship such as y equals 10x, into which each element x in one set, there corresponds a unique element y in another set. This is called a function. Y is sometimes referred to as a dependent variable, and x is the independent variable. The simplest way I can articulate, identifying a function, especially if you can see the graph. If you can see the graph, then basically it passes the vertical line test. That means that every x corresponds to exactly, or every y corresponds to exactly one x, right? You don't have, I think I said it right the first time, every x corresponds to exactly one y. You don't have one x corresponding to more than one y, right? In a graphical sense, these people have to wait. In a graphical sense, that's like if you have points on top of one stacked on top of each other. If you can draw a vertical line through your graph and it crosses the graph more than once, then it's not a function, right? And we'll see some other ways to kind of identify functions. Let's see. Okay. And we say that y is referred to as a dependent variable because it basically depends on which x you choose. Like you choose an x, it's an independent variable, you pass it through the function, and it's going to generate a set of outputs, which is the y or the dependent variable. Okay. So a function from a set x to a set y is a relation in which each element of x corresponds to one and only one element of y. The set x is the domain of the function. The set of those elements of y that correspond or assigned to the elements of x is the range, right? So your domain is your set of inputs, your range is your set of outputs. Every x corresponds to only one y. Again, you don't have one x corresponding to multiple y's, right? If that happens, then it's not a function. For each x in the domain of f, that corresponds a unique y in the range, basically a reiteration of what I just said. The number y is denoted by f of x, is read as f of x or f at x. Now, a common error here that students sometimes do, let me see. Sometimes students see this symbol here where they have f of x and they think that that's f times x, and so they distributed x. This is not multiplication, right? So this symbol here is not multiplication. This means the function evaluated at the value of x, right? So it's not multiplication. So be careful about distributing an x. Right? Again, that's a common error. Students try to distribute an x, and they're gonna be led astray. Okay. We call f of x the value of f at the number x, and say that f assigns the f of x value to x. Right? Okay. I'll check attendance in about a little over 3 minutes for the second wave. Functions can be defined by ordered pairs, tables and graphs, and equations. Okay. So to determine whether each relation defines a function, right? So this one, we're looking at a set of ordered pairs, right? Now you could plot all these points. If you have any points stacked on top of each other, they would essentially fail the vertical line test. You would have one x corresponding to more than one y, so then would not be a function. When we kind of have it displayed like this, in other words, if we have repeating x's, just like in life, if we keep going back to our x, there might be some dysfunction there, right? Possibly. This is a silly joke. But if we have repeating x's, then we can say that it's not a function, right? So like for instance, if we look at example 1, so let's use the reactions in Zoom. Let's see what my reactions are. So if I go to my reactions, if you're gonna say yes, a function, let's do the clappy hands. They need like a thumb down. If you're gonna say no, it's not a function, let's do the thumbs up, right? So let me make a quick note of that just so that people can see. Oh, you know what? That actually did work better. Let me screenshot. we're gonna go like this. And we'll just take this. The dog is warming up her vocal cords, just on patrol, pacing. Her pacing like makes me anxious. How do I undo that? Oh goodness, everything is gone. Shyster. I know I have it here. Can I edit this? Revert to the original. That's fine. Edit. I'm gonna hit done. Share. Copy. All right. Can we just paste? No. Okay. Paste. Come on. I know you could paste. Share. Copy. You are tripping today, my friend. Paste. You tripping. Share. AirDrop. Man, that's way too much. I shouldn't have to do all that. Yeah, like that's kind of what's been going on with my device all day. Like I have files, basically that I use. They're saved or whatever. I don't know. Let me try one more time. Paste. Paste the image, I guess. Okay, that's fine. The paste. Paste. Thank you. Jesus. All right, let's crop this because we only really need the first two. Okay. And so what we'll do, and I'll just kind of have this, if you feel like it's a yes, right? We'll do the applause hands for yes, it's a function. And we'll do I know that's a little bit confusing, but we're gonna say the thumbs up is a no, right? So we're gonna say, use this as a thing. So if we're gonna say yes, we're gonna do the applause hands. If we're gonna say no, we're gonna do the clapping hands. I'll put this like over to the side, okay? So in Zoom, all right, because I just want to get a little bit of feedback from you all. Let's see. So in this question, we're asked, determine whether each relation defines a function, right? So we did make a statement before I had to pause to figure out what's going on with my equipment. If you feel like A is yes, a function, you would do the clappy hands. If you feel like A is not a function, you would do no, the thumbs up, right? I know that's a little reversed. Just in the reactions real quick, all right? Let's give you guys a little bit. Can I see you guys' reactions? You guys there? Okay, I see at least one thumbs up, so that's a no, right? Okay, it's a little bit confusing. I see more. Okay, you guys are looking good. Okay, so let's see. So you guys are saying this is not a function, right? Okay, I think I can agree with that because, right before we did part A, we said that if there are repeating x's, then it's not a function, right? So if we were to plot these points, this -1 is repeating, right? So then we would have these 2 points would basically be stacked on top of each other. So they would fail the vertical line test. So I would agree with you all that this is not a function, all right? So we're going to say, just going to put it here, not a function, okay? If you feel like B is a function, can you do the clappy hands? If you feel like it's not a function, do the thumbs up. Who has one thumb and says it's not a function? That guy, all right? Okay, I see clappy hands, right? Yeah, I can agree with that, right? We're not repeating x's. Every x corresponds to only one y. That looks good. So we're gonna say just a function, like yes, a function. Okay. All right, this is a little bit of a random thing. Let me check on you guys on Zoom really quick, see if I got any stragglers, participants. Oh, I can't see it here. Let me move it here. Okay, I'll go ahead and get them. Update my attendance. He's going to be like there. Where is it? Nice. Okay. So this one. Okay. So let's see. Oh, the random story. So I went to the movies on last Thursday. Just a random. Nothing. It's nothing. It has nothing to do with anything. There's no point either. I went to go see Gran Turismo. I'm just doing free marketing for them, but actually that movie was better than I thought it was going to be. Like I actually enjoyed it. And then afterwards I saw Strays. I was like, Strays felt like they were trying too hard. Spoiler alert. Spoiler alert. Let me see. Is it professors? Attendance. Jones. Is Mr. Jones here? I don't know if he's in here right now. Let me see. Yeah. Mr. Jones, if you're talking about the email that you just sent, we can talk about it. Just remind me towards the end of class. And I'll probably just mark it as excuse. Like for the first few sessions, if anybody that essentially requests an excuse, because I know that we're all trying to get acclimated and kind of get into the swing of things. So I'm not going to penalize anybody for attendance, Okay, for right now. So just kind of remind me towards the end of class and we can update that. Okay, I would like to get a copy of this. This actually worked really well. It was much easier than like doing the polls. It's ready to go. Let's copy. Because polls is a little bit, extra. So this is not a function. So we got A correct. Oh, and I think that's good. All right. So the domain is going to be our set of input values, right? So, you can see them there. Basically our X coordinates, and our range is going to be a set of output values. Okay. All right, so we're going to let that be for now. Let's hop here, minimize. Yeah, I don't know. It's just like the time, I feel like I blink my eyes and the days are just whizzing by, right? So that's why I kind of structure the class the way I have a structure where this is intended to be remote asynchronous, where, at a minimum, you guys need to get your attendance credit on each day. And then most of the learning is done on your own. So that's why I made the pre-recorded lectures, because like we only meet for like 50 minutes twice a week, right? That's no time. That's nowhere near enough time to actually go through these details. So, again, most of the learning is on your own, and that frees us up during class time to kind of talk about whatever we want, right? As long as we're kind of like on task and not completely wasting people's time. Like I don't want to waste you guys' time at all. Okay, so let's look at this example. Determine whether y is a function of x for each equation. Okay, I'm thinking. Okay. The simplest way that I know to go about these is look at the graph, right? So, and the simplest way I know for you all to graph these for right now, we're going to explore more techniques on graphing. But for right now, the simplest way to graph is just by plotting points. So you choose several values of x, pass those x values through your function. You're going to generate several values of y. You look at the graph and then ask yourself, does it pass or fail the vertical line test, right? So make a table of points. Let me see. Yeah, that's the simplest way, right? Okay, so for instance, if we're looking at part A, so, and
Professor C.
Yes.
Your screen isn't shared.
Okay. Let's go here. Let's share the screen. Start the broadcast. Optimize the video. Okay. So in these two examples, we're asked to determine whether y is a function of x. What we're going to do is look at the graph, right? We're going to plot some points. So choose several values of x, find the corresponding y, and all that jazz. That would be nice if I could get that to work. That actually does come in handy. But I don't know if there's a simple way for me to do that without open up the settings. That's okay. I'm not going to worry about it for right now. So again, what we're going to do to plot these, at least for the first one, I think we can do it for the second one as well. We're going to choose several values of x, and then find the corresponding y and look at the graph, right? But for the first one, the first thing I'm going to do is set it to 0, right? So let's set it to 0, basically by subtracting 12 on both sides. And so we'll get 6x squared minus x minus 12 equal to 0, right? So I kind of want to just do a rough sketch. I don't really feel like choosing, like, you know what? Okay, I'll do this. I'll do the following. So we can still choose several values of x. Let me think about this really quickly. We got our y-intercept, okay. Negative b over 2a, so that's 1 over 12. So x is practically 0. I am not liking these values. So what I'm going to do to generate my my table, I'm actually going to use my calculator, my graphing calculator, right? So let me pull it up here. This one. Yes, thank you. Refresh, reload and refresh. Nice, okay. So I'm working on the TI-83 Plus, right? Sometimes students will use like Desmos or GeoGebra. Those are fine. Those are free online graphing utilities. You can use those, or make a table. So I'm going to go to my y equals, and I'm going to type. I'm going to type this one that I created. Let me think about it. Yeah. So I'll do 6x squared minus x minus 12. All right. And then now we could just look straight at the graph, but let's at least look at the table. So like if we wanted x to be what? Like let's see if we started at -3. So if I hop over to the table, right? And so basically what I did, I hit second graph because table is just above graph. And so it'll create a table for me, right? And so I'll log a few of the points, right? So let's say our x versus our y. Now when x is -3, the corresponding y is 45. We can capture that. Okay, that's fine. We'll go -3, -2, -1, 0, 1, 2, 3, right? These are just x values that I chose. I just chose these x values. Again, when x is -3, if we pass it through the function, the output is going to be 45. If you have like Apple device, like iOS, like an iPhone or a MacBook Pro or iPad or anything like that, they typically come with a spreadsheet software called Numbers, and you can create functions and equations and numbers. That's honestly how I do y'all's grades. I take the raw data and I'll create formulas inside of the spreadsheet, and then it'll automatically go through every row. It's like different techniques or whatever. What else? If you're on a PC, then you would have Excel. And being a student at Morehouse, I want to say that you all can get a free copy of the Microsoft suite. So that means like Microsoft Word, Outlook, Microsoft Excel, all the Microsoft stuff, you get access. As long as your Morehouse email is active, you register with your student email. I still use it as a professor because I still have .edu on my emails. So as long as you have you have access to an email that has .edu, you can access the Microsoft suite for free. Right. And so it comes with Excel, and you can do spreadsheets and things like this. Right. So that's just a little bit of things here or there. Okay. So let's keep going. Let's fill in this table. So then we have what? 14. I think when it's -1, we're at negative 12. Okay. What is that? -7, 10, and 39. So maybe the threes might be a little bit far. We might be better off ignoring the threes. Okay, let me shrink this down. Okay. Well, yeah, we'll just do a rough sketch. I can include the 3. So my x's go from -3 to 3. My minimum y value looks like it's like -12. And again, this is an approximation. There are some other techniques that we can invoke to be more precise. We're just trying to get a sense of the graph. So a rough sketch, a positive y is in this direction, positive x is in this direction, Let's see. We said the y's -12 to 45. So let's go to 50. I guess we on the like up to 50 and down to maybe like 20. All right. And the x's, so we can go like 1, 2, 3, 4. Trying to be as evenly spaced. I could introduce graph paper, but I'm just doing a sketch. 1, 2, 3, 4. Negative. We got our origin here. And on the y, we want to go up to 50. Let's see. Let's go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? So 10, 20, 30, 40, 50, right? So that takes, you have to, you have to identify your tick marks so that people know, what these mean. And then we want to go down to 20, 5, 10, 15, 20. Okay. So let's plot these points. So then, for instance, -3, 45 puts us like what, right about here. I'd like to go, let's copy and paste. Okay. And then what, -2, 14. That's right about there, just below the tick mark or whatever, paste. -1, 5 is here. Okay. 0, -12. So the y-intercept, right about there. So it's a little bit off. But again, the reason it's off is because I'm not working on graph paper. So that's why it might seem like a little off. If I did this on graph paper, it'll behave a lot better. And then 1, -7. Like right about there. And then 2, 10. It's about there. And 3, 39. It's pretty much at 40. Moodle. Oh, is there somebody? Let me check. There might be somebody in the waiting room. Let me check. I thought they could let themselves in now. The student. Oh, that's gonna be tonight. No, that's tonight. Here. Okay, I got it. Yeah, I think that's just a reminder for tonight. Okay. So, and then if we connect these with a smooth curve, now we didn't accurately capture the vertex. Like, I did a quick calculation as we were working on this, looking for it, but this gives us a sense, right? So say we have an image like this. Again, all we did, we chose several, and again, we're gonna, later on in subsequent sections, we'll go through details on, let's see. Yep. Let me check the chat really quick. I know you can't see my screen. Yeah, same. I can't see the screen. Same. I can't see. It's fine. Okay. So let me share my screen. Yeah, it's just throwing a tantrum. But again, in anticipation of these sort of tantrums, that's why I make all assignments available as early as possible. That's why I do my pre-recorded lectures, so that way, if it eats into our live time, you still have access to these materials. And I try to give you all a cushion as far as time and automatic extension built into all assignments and unlimited attempts, minimal late penalty. Honestly, anybody that really wants an A in this course, if you just go through sheer brute force and just keep submitting it, you can keep taking these assignments until you get essentially whatever grade you want. Right? There's nothing stopping you from doing it. Right? So it's really what you want. It's whatever you want. If you want whatever grade you want, anybody that wants it, you can get it. You just got to make up your mind, make a plan and take action, right? So notice that with an image like this, no matter, we can do this color. No matter where we draw a vertical line, it only touches the graph once, right? So now that we have a sense Oh my goodness. See, it just keeps, I'm coming. I know you guys can't see. It keeps kicking me off. I'm coming to let you guys back. Now, why it's behaving like this, I don't know. Mercury retrograde, who knows? Let me see. It's okay. Yeah, it's okay. I went on to mark you as present because I know how technology can be. Let me share my screen. It's even been thrown. It's been acting crazy for us as well. Try this again. Okay. So again, to generate this graph, we chose several values of x, found the corresponding y. Let me hop back here so I can see what you guys see. Close. Yeah, that looks good. Okay. Chose several values of x. This is being posted to this is live streamed to my YouTube, right? So you can always go back and rewatch this. Yeah. Okay. So again, we chose several values of x, passing through the function, found the corresponding y's, plotted the points. We got an image like this, and then notice that no matter where we draw this vertical line, it only touches the graph once. All right. So we could put the vertical line anywhere, and it'll touch the graph only one time. So then, is this a function? We would say yes. This is a function. All right. So I'm going to shrink this down just so I can say yes. Okay, we're going to say yes, this is a function. Okay, but we did this one by looking at the graph. I know it didn't kick off. Oh my goodness. Zoom, what are you doing? You're getting on my nerves. Yes, a function. The screen sharing, you might need to reboot this device if you cannot restart broadcasting to Zoom. And the funny thing is, I literally had just rebooted my device right before starting class. Let me share my screen, start the broadcast. And right, so for part A, we got that it is a function. We got a solid 10 minutes, so let's try to maximize it. Now for B, we can still do the same thing. So for B, let's solve for y, right? So we have this y squared minus x squared equals 4. Okay. So if we solve for y, we're going to get what? Y squared equals x squared plus 4. Okay. So can anybody tell me how do we get rid of that square root on that squared on the y? How do we get rid of that squared on the y? A hint is I accidentally said it right when I started this. So feel free to either unmute yourself or type it in the chat. All right. How do we get rid of the squared on the y? We take the square root on both sides, right? So if we took the square root, right? So we take the square root here. Next question is, riddle me this. Generally speaking, whenever we introduce square root, what symbol should also generally accompany square root? Let's say that one more time. Whenever we introduce square root, what symbol should we be cognizant of? All right. So whenever we take square root, like if we introduce a square root, fourth root, any kind of even root, generally speaking, based on the context, we need to introduce a plus or minus. All right? We need to introduce a plus or minus. Let me see. Right. So on the left, yeah, these guys are going to cancel. And so we're going to be left with y equals plus or minus the square root of x squared plus 4, right? So the square root, what this image looks like again. Now, once we get it into a form like this, we can kind of repeat, but we're going to have two graphs, all right? So we can still choose several values of x find the corresponding y, but we're going to get two results, right? So as a extremely rough sketch, I'm watching the clock, by the way. This is a rough sketch. We should have an image, matter of fact. Something, oh my goodness, you went off again? Like I can't make a move without you cutting out. Why do you keep cutting out? Yeah, that's why I monitor it. Yeah, square root. Okay, that was fine. Share the screen. Okay. At least the image is coming back. Maybe I spoke too soon. So this image is going to be something. Now, again, this is just a rough sketch, but it's something along the lines of this. Like it's like that, and it's something like this. So suppose, let me think about it. Let me confirm it. I might have it positioned wrong, but that's the gist of it. Let's pull this one. And so to get a better sense of the image, what we can do, I'm going to graph it in my trusted Dusty Rusty. Okay, at least that's working. Reload and refresh. Okay. So I'm going to graph it here, right? Again, we introduced the plus or minus. So whenever we take square root, we have to introduce the plus or minus. So then to graph this, we can hit square root. We can say x squared plus 4, right? And then we have a second graph, negative square root, x squared plus 4, okay? So then I think the window should be fine. Oh, I got the image wrong, but okay. So I was like, well, let me look at the graph. But I knew it was something kind of like this, right? And again, we probably should have chosen several values of x, plotted the corresponding y's. We get an image like this. I was just trying to rush. So, but if we have an image like this, so we get something sort of like this and something like this, right? If we have an image like this, does this image pass or fail the vertical line test? All right, does it pass or fail the vertical line test? Notice that we can draw a vertical line and it indeed touches the graph more than once, right? I'm glad I checked that before going with that wrong image. I would have felt real bad about that. Because I wasn't really thinking. I'm just like, I knew it was like something that was going to fail, mainly because of the plus or minus, right? You can find one x that corresponds to more than one y, namely, like, for instance, when x is 0, y is going to be plus or minus 2, right? So then that's one example that one x corresponds to more than one y, so then this is not a function. Let's try to do one more example and then we'll call it a day. Okay. Okay, that's fine. Defined by this equation, evaluate. Okay, so we're asked to basically evaluate these guys, evaluate the function. So I'm going to use my calculator whenever possible, right? I don't think we can use it for all of them, but we can use it for many of them. So my function is x squared minus 6x plus 8. So x squared minus 6x plus 8. Okay. So then to evaluate this function, on the right-hand side of the calculator, there's a button that says clear. Just beside that to the left is a button that says VARS. I think that's short for variables. I'm going to click on that button. I'm going to go to the right to go to Y variables. I'm going to click on number 1 for function. Number 1 again to call in the function I just inserted. So now we're going to evaluate the function, namely, let's see, when x is 3, we get an output of -1. So I'm just going to, basically just plugged it in. G of 3, we got our x squared. Let's clean it up. X squared minus 6x plus 8. Nope. Minus 6x plus 8, right? And okay, I'm kind of out of time. Style. So again, all we did was plug in when x was 3. 9 minus 18 is -9 plus 8. We're getting what? -1? Yeah, -1 is correct, right? Okay. Let's see. Let's copy that. This, that, not that. This. No, I was just about there. Oh, come on. All right, I think we got to call it a day. Still, now, okay, let's try this one more time. All right, let's copy, paste. Nice. Okay, so that was part A, and then part B. Was A, part B. What x is -2, so -2, -2. That's a 4 plus 12 is 16 plus 8 is that 24. So when we did it just now, we got 24. And I'm about to let you guys go. Let's confirm this with a calculator. So all I'm going to do is recall what I did before and change the 3 to a -2. And they got 24 as well, right? I'm going to have to leave the rest as an exercise. So again, in my pre-recorded lectures, it should be the same content, but it just finishes out the section. Let me go ahead and make a copy of this available. I want to share, send it to bots. Fall, traditional, this, notes, updated daily. That's fine. It's just going to have to go here.
Morehouse?
So when this bar finishes loading, you'll receive a copy of whatever you saw me writing, and plus a remainder of this section. Also, just as a reminder, hopefully you all have also connected with Dr. Lamar regarding the lab, right? So you are responsible for, there is a lab component to this. To access the lab, basically on our Blackboard page on the left-hand panel, just below where it says course content, there's a link that says Alex Lab and Syllabus. Click on that link, contact Dr. Lamar and follow her instructions. And basically at the midterm and the final, she's going to give me a grade for each student in lab. I'm going to take that grade and scale it to 10% of your overall grade. I do see the screen just cut out, but we're essentially done. Yeah, and so also just, you can anticipate exam 1 to become available this upcoming Sunday over sections 1, 1, 1, 2, and 1, 3. Are there any burning questions before we go our separate ways for the day? Going once. Going twice.
When do we join the online lab class?
You said when?
Yeah.
Right now. Like just go to Blackboard and reach out to Dr. Lamar and follow her instructions.
But there's an online class for it?
Yeah. So the online lab is separate from what we do. We do our stuff in the lab. The online lab is something that's separate that you're responsible for.
Okay.
Mm-hmm. Any other burning questions? Going once, going twice?
I didn't. Can you say that 10% thing again? I didn't get
It's
all
a component. Whatever you do with Dr. Lamar, that counts for 10% of your overall grade.
What we do in there? We just do the little Alex thing. How does that get graded?
She grades it, and then she sends me a grade for each student. Yeah.
Okay.
Mm-hmm. I know there was one student that was concerned about attendance, so as soon as we stop the stream, I'll try to stay on for just a moment. So if you have questions about that. If there aren't any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace. Okay, let me stop the live stream.